Okay, I had a question on why the this linear function and why the square root function were neithers in terms of even, odd, or neither. So let me kind of do a couple that work here first. Let's see, there it is. So for a classic even function, that would be like a quadratic at x squared. It's an even power. That's why they call it even functions. And if you think of this thing, if you thought of this as a piece of paper and you have this axis right here, if you folded the paper right across there, this branch of the parabola would sit right on top of that branch. So that is what an even function looks like. Same thing here, if you folded this paper for this edge to this edge, then that line would be sitting right on top of itself. Another thing with even functions, if they have the point, for instance, 2, 4, they're going to have the opposite, for the opposite x, -2, it will have the same output, 4. So we saw that in the definition. So it's going to have opposite points around the vertical, or what we generally think of as the y-axis. So that's even. And then for odd, so the geometry is a little harder. It's much easier if I'm in class and I can point at it, but if you picture cubes, that's x cubes, that's an odd function. If you picture folding this piece of paper across this line right here, folding it up, and then quartering that and folding it over, then it sits on top of itself. So that's sort of the geometric symmetry for that. So again, if you fold it up and then over, likewise you could fold it long ways and then quarter it again this way, it's still sitting on top of itself. For this one, I think it's much easier to look at the points and see if it's an odd function. So for an odd function, if it has the point 1, 1, it will have the exact opposite of that, -1, -1. This one would have 2, it would go up here to 8. This is going to be when x is -2, you get out the opposite, you get -8. Identity function, there's another example of an odd. This has 3, 3, so it's also going to have -3, -3. So for an even function, if we just fold it across the y-axis, it should sit right on top of itself. For an odd function, again, there's that folding thing, but I think that one's easier to just look at and go, okay, it has 3, 3, so it has to have -3, 3. So now if I try those two things to these two functions, if I fold this piece of paper across, it does not sit on top of itself. And again, with these ones, if this has the point 2, 4, it has to have the opposite, -2, same y value, 4. And neither of these ones do that, so those are definitely not even. And then in terms of odd, if this one has the point, it looks like it goes through 1, 1, but it does not go through -1, -1, so it's not odd. This one goes through 1, 1, it has nothing down here, so that's not odd. So if it's neither even or odd, then it's just a neither. And so that is why those two are neithers.